Haley,
Yeah.
what time is it?
It's pizza time!
Big shout out to fourth period right there. I'm sorry to everyone else who just had to experience that. Got a few announcements for you guys for the rest of the week. Tomorrow we have a quiz. Geometry, you guys are taking your quiz on section 11.1 through 11.3. Algebra 2, you guys have your quiz on section 4-1 only. So just like before, first group will be going at 10 a.m. for the quiz. Second group will be going at noon. I'll send you guys an email if you're in the second group. If for whatever reason you can't take it at 10 a.m., let me know, and I'll put you in the second group. But please try to take it at 10 a.m. if you can. I'll be giving you guys 40 minutes to do it. Hopefully that's enough. And also, when you submit your photo, make sure that it's a vertical photo, not a horizontal photo. The horizontal is really, really hard to grade. Also, we got some good news for you. You're going to be super excited about this. You don't have any homework over spring break. None. But with that being said, you guys do have a homework assignment that's due at midnight on Friday. So Friday's lecture, the homework for that lecture will be due at midnight on Friday. Sorry, but that's just what's got to happen. So to make it a little bit easier, what I'm going to do is make the video lecture available on Thursday. So if you guys want to get ahead, feel free to watch it Thursday and submit the homework by midnight on Friday night. And then you have the whole week of no math. No seeing me at all. All right, that's it from me. Hope you guys enjoy the lecture. See ya. All right, today we're looking at section 4-2b, writing and graphing inverse functions. So this is going to be pretty close to what we did yesterday. We're still going to be having a function and finding the inverse, but now the difference is that we're just going to be graphing both the original and the inverse function. So to do this, we're going to be using slope-intercept form because we will be dealing with linear functions. So if you recall slope-intercept form, y equals mx plus b. Now slope-intercept form, what's the two things that we have? Well, we have the slope and we have the y-intercept. So this, m is my slope. Remember, slope is rise over run, or the change in y over the change in x. And then b, that is my y-intercept. So on my xy axis, that's where my function, whatever my function is, that's where it crosses the y-axis. Is that y equals, let's say 3. And then y and x are obviously the variables, but the key here is that we have our slope and we have our y-intercept. So when looking at this, our first example, let's go ahead and graph this function here, 3x plus 6, and then write the inverse and graph the inverse. So to start, let's go ahead and take the f of x equals 3x plus 6. Very first thing I'm going to do is just change the f of x to y. Really don't have to do this, but I'm just going to do it because when we find the inverse, we're going to swap that x and y. So to graph this, let's first go to my y-intercept, which is 6. So I just go up 6 units, 1, 2, 3, 4, 5, 6. And then my slope, the slope is 3. But you rise over run, so that's really a 3 over 1. So I'm going to go up 3, because it's positive, I'm going to go positive, so to the right 1 unit. So I'm going to go up 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, over 1. I could also go 1, 1, 2, 3, like that, because I still have my positive slope here. 1, 1, 2, 3. So this is my, let me do it this way actually. Let's try that one more time. Close enough. Why is this not working? So there is my linear function. I'm going to go ahead and label that as well and say that's f of x. That's my original function. But now let's go ahead and solve for the inverse function. So the inverse function, remember, this is where we swap the x and y. I swap x and y, and then I solve for y. So if I take this function here, I swap x and y, that'll give me x is equal to 3y plus 6, and now I just solve for y. So I'm going to subtract 6 from both sides. That gives me x minus 6 equals 3y. Now I divide both sides by 3, divide by 3, and that gives me y is equal to x minus 6 over 3, which then I'm going to further simplify this to, with the correct notation, the inverse function of f of x is equal to x over 3 minus 6 over 3, which reduces to 2. So this is my inverse function. Now let's go ahead and graph that. So my y-intercept is negative 2. It's right here. And then my slope, well, what's my slope here? Now it's x over 3. That's the same thing as 1/3 x. So my rise is going to be up 1. So up 1 over 3. So up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Could also go 1, 2, 3 over down 1. And then to graph this, you really only need 2 points to graph this. Let's try that one more time. So there's my inverse function. Make sure you label this. Oops. If you want to use 2 different colors, that's great. You don't have to, but you do have to label which is which. Make sure you do that. So there's my inverse function, and again, note that this is reflected over the diagonal line right here. You don't have to graph this diagonal, y equals x, but just notice that there is a reflection going on. So that is your, we've graphed the original, we found the inverse function, which is right here, and we also graphed the inverse function. Let's go and do one more example. Graph f of x is equal to x over 4 minus 5, then write and graph the inverse. So go ahead and pause the video, try this one on your own. Assuming you did that, let's first write y is equal to, now this x over 4, that's the same thing as 1/4 x minus 5. So I go down 5, because that's my y-intercept. 1, 2, 3, 4, 5 right here. And my slope, the 1/4, I'm going to go up 1 over 4. They're both positive, so I go positive, because this is positive, this is positive, this is negative, negative. So I'm going to go up 1 over to the right 4. So go up 1, 1, 2, 3, 4. Up 1, 1, 2, 3, 4. Could also go 1, 2, 3, 4 to the left, down 1. And again, you really only need 2 points to graph this, because to make a straight line, you only need 2 points. Like so. So this is my original function. I'm going to label it f of x. Now let's find the inverse. This is where I swap my x and y. So I get x is equal to 1/4 y minus 5. I'm going to add 5, just solve for y. So x plus 5 equals 1/4 y. Now I'm going to multiply this by 4 so that those 4's cancel out. What I do to one side, I do to the other. So that gives me y is equal to 4 parentheses x plus 5. But I'm going to distribute, like so. And then I'm also going to write the inverse notation. So f, the inverse of x is equal to 4x plus 20. So that's my inverse function. Now to graph this, notice that my y-intercept is 20. So I'm going to go 1, 2, 3, 4, 5, 6, 17, 18, 19. So 1 unit above the top of the screen here is 20. And then I'm going to go over down 4. So the slope is 4 over 1. So I'm going to go 4 units up over 1 unit. I could also go, since that would put me off the screen, you also could go 1 unit to the left and then down 4 units. So I go 1 unit to the left, 1, 2, 3, 4. 1 unit to the left, down 1, 2, 3, 4. Like this. And that would be my equation here. This is my inverse function. And notice, let's double check that. Does it look like it's being reflected over the line y equals x, this diagonal here? If we check that, notice that this intersection does fall on that diagonal. So yes, it does. Now, if you were doing this on a homework, you could also go by, because the y-intercept is so high, it's 20, you could also go by 2's if you wanted to. So this could be 2, 4, 6, 8. That's a possibility to make it where everything falls in the graph, or you can just make a big giant graph. It's up to you. Last thing I want to review is, let's say you had a function like this. Let's say negative, actually 2 more things we're going to go over really quick. 1/2 x plus 1. So if I had that function there, if I wanted to graph this, well, what's my y-intercept? My y-intercept is 1. So I go right there, and my slope is negative 1/2. So this negative, you're only going to use it once. You can use it on the top, or you can use it on the bottom, but you only get to use the negative once. So I'm just going to say negative 1 over 2. And so the negative 1, so that's my negative direction. So I'm going to go down 1 and then positive 2. Down 1, positive 2. If I wanted to use it on the bottom of the negative, I could also go positive 1 and then negative x direction, negative 2, so to the left. Up 1, negative 2. So when you have a negative slope, you only get to use the negative 1 time. And then you connect everything. And it's a negative slope, so just think downhill. This would be positive. This would be a negative slope, downhill. Last thing I want to review really quick is, let's say that you had f of x is equal to negative x minus 1/2. What if you have a y-intercept of a fraction, a half, a third, whatever? So do this. We've gone over this before, just to review. It's just not working. So my y-intercept is negative 1/2, so I'm just going to go down half a unit. And my slope is negative 1 over 1, so I'm going to go down 1 unit. But I don't go on these, right, because I have to go down 1 unit from my y-intercept. So it would be right there. So that's down 1 unit. And then I go +1. So I go +1. Now I just go 1 full unit. So right here. So that would be my new point. Is right here. I could add another one, go down 1 over 1. And so I could go up 1 over 1, which is right here. But the key is that whenever you go up, down, left, right, you have to go from the y-intercept, and that's what determines the rest of the points. And again, negative slope, so I'm going downhill. Alright, so again, you guys do have your quiz this Thursday, only on section 4-1, so this 4-2 will not be on the quiz. That'll be next week or when we come back from spring break. This is a little bit easier section, so we're just going to put on the next week's quiz. But yeah, if you guys have questions, make sure you shoot me an email, and then we can get it figured out. Alright, have a good day.